Hello everyone and welcome back. We are looking at some more surds, and in this lesson we are going to be focused on conjugates and rationalizing denominators. We are going to be looking at these individually. So we want to look at how to rationalize a denominator, and we want to use conjugates. Now, let's start first by understanding what we mean by rationalizing a denominator. Now, if a fraction has a surd in its denominator, for example, if we have 1 over root x or 1 over root 3, that's what we mean by having a surd in its denominator, we can rewrite the fraction with a rational denominator. And that is what it means to rationalize a denominator. How do we do this? To do this, we multiply both the numerator and the denominator by the square root in the denominator. So that's what we do. So if we want to rationalize a denominator, what we do is that we multiply our fraction by the square root in the denominator. Let's try that real quick to make sure that it sticks. So here we have a couple of questions to work on. So we have 2 over root 3. And we want to rationalize these, and what we want to do then is to multiply by the square root in the denominator. So we're going to multiply this question. 2 over root 3 is going to be equal to 2 times root 3 over root 3 times root 3. So we multiply the numerator and the denominator by the square root in the denominator, and what we end up with is, in the numerator we have 2 root 3, and in the denominator we have root 3 times root 3, which simply is just 3. Root 3 times root 3 would be root 9, and the root of 9 is 3. So that would be our answer there, and that is the rationalized form of the denominator. Once you rationalize the denominator, you would end up with a real number here, usually an integer of sorts in the denominator, all right, and not a square root with an irrational number. So here, let's try it again. Here we have 7 over 2 root 5. And so what we're going to be doing is to say 7 times, we're going to multiply root 5 over 2 root 5 times root 5. And so in the numerator, we have 7 root 5 over 2 times root 5 times root 5. Now remember, root 5 times root 5 is 5. So this would be 2 times 5, which gives us 10. And that is our answer there. This one looks a little bit more challenging. So let's try it, but the idea is the same. We're going to multiply root 7 plus root 3. We're going to multiply that by root 7. And multiply the denominator 2 root 7 by root 7. Okay, and once we do that, then we can see that in the numerator, what we will have is root 7 times root 7 plus root 3. And in the denominator, that's the numerator, in the denominator we have 2 times root 7 times root 7, which means 2 times 7. And 2 times 7 is 14. Of course, we could multiply the top here to say root 7 times root 7 would be 7. And root 7 times root 3 would be root 21 over 14. And of course, that would be the same answer as above. So the idea here is that if you want to rationalize a denominator, then what we do is that we multiply both numerator and the denominator by the square root part of the denominator. All right. Let's look at this. Here's a question, 3 over root 8 plus 5 over root 2. So how would we do this? Well, we can start it off first by simplifying each one of these by rationalizing the denominator. So we can have 3 over root 8 times root 8 over root 8 plus 5 over root 2 times root 2 over root 2. And here we have 3 root 8 over 8 plus 5 root 2 over 2. And now we can add them. So they have different denominators. So we can multiply this one by 4. So this would give us 3 root 8 over 4, rather over 8. Let's just write that. Plus 4 5 is 20. 20 root 2 over 8. And now that they have the same denominator, we can go ahead and add the numerators, which would be 20 plus 20 root 2 plus 3 root 8 over 8. And that would be your answer there. Of course, this answer can be simplified in many ways. Root 8 here can be written as root 4 times 2, which gives us 2 root 2. And we can rewrite that as 20 root 2 plus 2 times 3 is 2 times that 3 over 8. And that comes out to give us 2 times 3 is 6. So we have 20 root 2 plus 6 root 2 over 8. And that would give us 26 root 2 over 8. And of course, we can even simplify it some more by dividing both of these by 2, which would give us 13 root 2 over 4. Now this is still the answer, just a simplified version of that. So the idea there is that if you want to rationalize your denominator, then what you do is that you multiply both your numerator and your denominator by the square root part of your denominator. We did this here, and got some integers in our denominators, then went ahead and add the fractions, then simplify the answer. Now let's talk about conjugates. Conjugates are defined as a pair of binomials with identical terms, but they have different arithmetic operators. So here we have two expressions, x minus 2 root y and x plus 2 root y. Now both of these are conjugate to each other. Notice that it's the same x and 2 root y in both, but one has a minus and one has a plus. So x minus 2 root y is the conjugate of x plus 2 root y, and x plus 2 root y is the conjugate of x minus 2 root y. Now let's multiply an expression by its conjugate and see what happens. So let's multiply x minus 2 root y by x plus 2 root y. Now x times x here gives us x squared. So we have an x squared there, and x times 2 root y gives us a plus 2x root y. Multiplying here, minus 2 root y times x gives us a minus 2x root y, and a minus 2y times a positive 2y gives us 4, not a plus 4, that's a minus 4, minus 4y. And so these are similar and they cancel out each other. So what we end up with when we simplify this is x squared minus 4y. So this is important to remember, that the product of a binomial, surd, and its conjugate is always rational. It's very, very important to remember. The product of a binomial, surd, and its conjugate is always rational. Now let's look at some more questions. Here we want to write down the conjugate of this, and remember the conjugate is to be the same expression with a different sign. So we simply say that the conjugate of this is root x. Here's a plus, so we write minus root y. And in this one, the conjugate of this expression, 2 root a minus 3 root b, we write it back, 2 root a, and we change the minus to plus. plus 3 root b. So there's no big challenge in writing down the conjugate. This is its conjugate. This is the conjugate. All right. Now that we know how to write down conjugates, let's now learn about how to rationalize a denominator. Now, if a fraction has a denominator of the form 1 over a plus b root c, then we multiply both the numerator and the denominator by the conjugate of the denominator. So earlier we would have rationalized the denominator with when we have 1 over root 5, and we could easily say that is equal to 1 over root 5 times root 5 over root 5, and that would give us root 5 over 5. So this is how we rationalized earlier. But now we have a more complex expression in the denominator where we want to use the conjugate instead to multiply both numerator and denominator. So if a fraction has a denominator of this form, we cannot just multiply by the square root part. We have to multiply by the conjugate of the denominator. Let's try it out. So here we have 1 over 1 plus root 2, and we want to multiply by the conjugate of this. So this would give us 1 over 1 plus root 2 multiplied by 1 minus root 2, which is the conjugate of this, 1 minus root 2. So let's bracket that. And so in the numerator, what we will get is 1 minus root 2 divided by 1 times 1 is 1. 1 times minus root 2 is minus root 2. And root 2 times 1 is root 2. So you notice that these are going to cancel out each other. And root 2 times root 2 is root 4, which is 2, but it's a minus here, so it's minus 2. And so what that gives us is 1 minus root 2 over 1 minus 2, which is 1 minus root 2 over negative 1, which we can also write as root 2 minus 1. So that's how we go ahead and rationalize the denominator of this. Let's try another one, which is a little bit more complicated. So here we have root 5 minus root 3, and we have as its denominator root 5 plus root 3. So we're going to multiply by the conjugate. So we have in the numerator root 5 minus root 3, and we're going to multiply that by root 5 plus, not plus, writing down the conjugate, so we're going to write down minus root 3 over root 5 plus root 3 times root 5 minus root 3. So we're multiplying the numerator and the denominator by the conjugate of the denominator. And here we end up with, in the numerator, here, root 5 times root 5 gives us 5. Then root 5 times root 3 here gives us minus root 15. Root 5 times root 3. And then here again, another minus root 15. And root 3 minus root 3 times minus root 3 gives us a plus 3. All of that over root 5 times root 5 is 5. And that is minus 3 there. So we end up with, in the numerator, 5 plus 3, that's 8. Minus 2 root 15. Minus 1 and a minus 1. And that is written over 2. 5 minus 3 is 2. We can further simplify this, dividing both numerator and denominator by 2. 2 into 8 here gives us 4. And 2 into 2 gives us 1. So that's 4 minus the square root of 15. So this would be a further simplified answer. And so it's a very, very useful technique to learn. Very useful, especially when you want to evaluate the limits and things like those. So it's useful. It's a very useful idea to learn how to rationalize a denominator and how to rationalize using the conjugate of the denominator. Now that you've seen how it's done, remember to practice. And of course, remember, if you haven't subscribed yet, please do so. We thank you for your support and thank you so much for watching.